for the answer. Let's do some more examples. This time let's look at multiplication and division. That's actually quite a bit easier to do. Because in the case of multiplication and division, the number of significant figures in the answer should be equal to the least number of significant figures of any of the quantities you use in the calculation. So you just look for the least number of significant figures of the numbers that you're using when you're doing a multiplication and division, and that is the number of significant figures in the answer. Here's an example. 12.3 times 5.0. Well, that would equal 61.5 if I plugged it into the calculator, but the number with the least number of significance going in is 5.0, which has two significant figures. So my answer also must have two significant figures. So I'm going to round my answer to 62. The same is true for division. I can take the number 16.7 and divide it by 9.004, and my calculator might actually give me 8 decimal places. But if I just wrote down a few, I would say 1.8547. But I see that there, in this case, the quantity going in that had the least number of significant figures had 3 significant figures, so my answer should also have 3 significant figures. It doesn't matter how many quantities you're using. If you're only doing multiplication and division, you just look for the quantity going in that has the least number of significant figures, and that's the number of significant figures in the answer. It's quite a bit simpler than the addition and subtraction case. Here's another example. Here I have all multiplication and division as my operations. So in this case, I look for the quantity going in that has the least number of significant figures, which here is 3. I have 3 significant figures in each of those and 4 in the other number. So my answer should have 3 significant figures. It should be expressed to 3 significant figures. Why am I doing that again? I'm doing that to show the level of precision. Okay, and we don't want to show a level of precision that is higher than what we actually had in any of our individual measurements. Now remember, when you do math, you have to perform certain mathematical operations in the correct order. So you do the operation that's inside the parentheses first, then you do multiplications and divisions, and then you do additions and subtractions. You have to be careful here about what happens to the number of significant figures when you do each operation. I like to keep track of the significant figures by underlining the last digit that's significant in any intermediate answer that I have. Remember, in addition you might gain a significant figure, and in subtraction you might lose a significant figure. So let's do an example of that. In this problem I have 2.86 minus 2.43. That's inside the parentheses, so I would do that first. The number that results from that doesn't have 3 significant figures, even though both of those numbers do have 3 significant figures. The number that results from that is 0.43, and it only has 2 significant figures. Okay, so just from looking at what's on this side, the parentheses, the answer from that, remember, can only be to the 100th place because I'm using the decimal places when I do subtraction. That has 2 significant figures. I then take the number with 2 significant figures and divide it by 10.57 to give me an answer of 0.04068, which I'm going to round to 2 significant figures, 0.041. Let's do another example. 3.58 plus 6.73. In this case, I have 2 quantities that each have 3 significant figures in the measurement, but both of those measurements were precise to the 100th place. So when I add them together inside the parentheses, I get an answer of 10.31. That has 4 significant figures. Therefore, when I take that 4 significant figure number and divide it by a 5 significant figure number, my answer needs to be expressed to 4 significant figures. Does that make sense? Now, it looks like when I'm doing these operations that I might actually be rounding during an intermediate operation step, and you need to be really careful about that. So I'm going to give you a quick word about rounding errors. One of the things that can happen if you have a calculation where, let's say, you have 5 or 6 different operations that you need to do in the calculation, is that if you round an intermediate calculation, you can end up with lots of errors. So what I recommend that you do, and I'll show you an example so you see what I mean, is that you always carry at least one extra non-significant digit through the multi-step calculation and then round at the end. And I actually like to carry a couple of extra digits the whole way through and use a line to underline the last significant digit to help me keep track. So here's an example. I can take the number 12.456, multiply it by 12, and then divide it by 3.697. The result of those operations is the answer 40.43. Now, there's two significant figures in the quantity going in that have the least number of significant figures. So my answer should also be expressed as two significant figures. And I can do that again by either showing that decimal point or using scientific notation. So I can say 4.0 times 10 to the first power. If I do the calculation inside the parentheses and round it, and then do the second calculation, I can introduce quite a bit of error. In other words, if I did it in two steps, if I took 12.456, multiplied it by 12, and got 149.47, but then I rounded it to two significant figures, okay, and then I take that quantity, which is 150 now, and divide that by 3.697, now my answer becomes 41 if I round it to two significant figures, and that's quite a bit different than 40. How much error have I introduced? I've introduced a 2.5% error. That can be a really large error. A difference in 2.5% concentration of something in your bloodstream, for example, could be toxic. Missing by 2.5% if you're shooting at the moon could mean you just fly off into interstellar space. So 2.5% can be a really big mistake. It's important to not do intermediate rounding. What I could have done when I did this two-step calculation is instead of rounding it to 1.5 times 10 to the 2, what I could have done is written down my intermediate answer and underlined the 4, just to remind myself that I only had two significant figures. That's one way that I do it, something you might want to try.